The second part of our lesson today is dealing with word problems. A lot of you always ask, when are we ever going to use this stuff? Well, word problems are when we use it. So we have Marty here. He is spending money at a rate of $3 per day. And after 14 days, he has $68 left. We want to know how much money he will have left after 20 days. And this is a great example because we want to know, how long will it be before Marty has to get a job and support his spending habit of spending this $3 per day, which I'm guessing is probably for lunch. So our step that we have first is going to be to determine the rate of change, or M, and interpret it. Now, we talked last week when we did our Learning Target 17 review on looking for those keywords, and that keyword, one of them, was that word per. Because if you remember, your rate of change is going to be that change in y over that change in x, which means that you're looking at a number with two different labels referencing it to make that comparison. So that means that this is going to be our M, which is he is spending, so it's -3 over 1. And we need to interpret it, so that's -3, and that's dollars per day. So we know that our x, or our independent variable, is going to be days, and that y, or our dependent variable, is going to be money. The next step is going to be to determine a point and label its units. So when I look here, we're looking at money and days. And so when I see here, I see that we have 14 days and we have $68. And so we need to make a point, and we're going to label the units right in there. So we said our x was going to be days, so we have 14 days, comma, and our y value is money, and in 14 days he has $68. So now our next step here is going to be to write the equation in our point slope form. So if you recall again, our point slope form is y minus y1 equal to our slope, or m, times x minus x1. So when we put our numbers in there, we have here that we have y minus y1, which is 68, equal to our slope, and I'm just going to put in the -3 because we don't need the over 1 in there, times x minus x1, which is 14. So there is our equation that we have got. So then our fourth step is going to be to then solve to get the solution to the question. So our question wants to know is how much you'll have left after 20 days. Well, this is kind of a screwy equation, so if you recall, it's a lot easier to work with slope-intercept forms. First thing we're going to do is get this solved for y, because it'll make our life a lot easier. So we have y minus 68, and I've distributed that -3, so we get -3x, and negative times negative is positive, and 14 times 3 is 42. So then I can go ahead and add 68 to both sides, which gives me y is equal to -3x plus 110. And if you recall from our knowledge of slope-intercept form, this is our y-intercept. That means that my ordered pair would be 0, 110, which means that at 0 days, he has $110, which means that Marty started out with $110 at the beginning of all this. Now I realize that that doesn't really answer our question, so now we're going to go ahead and answer our question. We said that our days is our x, so we're going to put in 20 right here. So we can go ahead and say, well, we've got y, which is our amount of money. It's going to be to -3 times 20 days plus $110. Well, -3 times 20 is -60 plus $110, and -60 plus 110 is going to be a positive $50, which means that at the end of 20 days, he will still have $50 remaining. Let's take a look at another example. Now we've got here the math department sponsors a math family fun night each year. The first year there were 35 families, and the third year there were 57. Predict the number of families that will attend the fifth year. When I look here, I don't see any per, which means I don't have that rate of change or that slope. So we're going to go about solving this one just slightly different. So the first thing we're actually going to do is determine our points and label our units. So I see here that we have first year, we have a third year, and then obviously we're asking about the fifth year. And we've got 35 families and 57 families. So we always talked about how time is always independent, which means it's always X. So we have here, first year, we had 35 families. And the second year, or sorry, the third year, we had 57 families. So I've got my points and I've got my units labeled so I know what I'm talking about. Step 2, we want to calculate that slope, that change in y over change in x. Well, we've already kind of have it set up in that XY table format. And I see here, this went up 22 families and this went up 2 years. So my change in y is 22 families over 2 years, which if I simplify that, that simplifies to a slope of 11 family increase per year. So now I got my slope. Step 3 is going to be to write our equation. So we can use either of our points. I'm going to choose this first one just because it has the 1 in there. So I've got y minus y1, which y is going to be 35. y1 is going to be 35. Our slope is 11 times x minus x1, which happens to be 1. So now I can go ahead and simplify this because now that we've got our equation, step 4 is going to be solved to get the solution to the question. So I go ahead and y minus 35, and I'm going to distribute that 11 to get 11x minus 11. So then I can go ahead and add 35 to both sides to get y is equal to 11x plus, and now because the signs are different, we actually have to subtract, so we get 24. And so then I can go ahead and say, well, predicting based upon this information, I'm going to put in my 5 right here. So then I have here y equals 11 times 5 plus 24. So that gives me 55 plus 24. So my estimate is going to be that I have 79 families that will come that fifth year. What you need to do now is go ahead and try these 2 triad problems, and then go ahead and answer your questions, try to write your summary, and bring your questions to class.